Well, thank you everyone, and again, thanks for Dia for inviting us here in this session. I'm going to talk a little bit differently about some of these technical guys that are here, and we're new to this whole heating and district heating network side, but we come from a different background in some respects. But one of the things we do have in common is that where we take heat from, and the biggest battery and the biggest heat source we do have is coming from our underground in the subsurface, and it's there indefinitely all the time. It's inexhaustible energy, and it's there forever. And why this is important is I come from an oil and gas background and spent over 35 years in the dark side of energy, producing fossil fuels. However, what we've really looked at is really the ground source heat pump sector is very much the same as oil and gas, but in a smaller scale. So what we've done is really looked at it in a different perspective and said, well, what about if we take an oil and gas approach to the ground source heat pump department and look at drilling deeper wells which can produce a lot more energy, meaning you use less space, certainly more expensive, but it's a way of actually producing a lot more energy from a resource which is there under the ground. So what our real goal is really looking at how can we make that competitive, how can we make that really an anywhere solution, looking at a monobore type system. So rather than looking at the conventional sort of EGS geothermal solution where you're driving in or drilling into an aquifer or some sort of subsurface hot rock which you have to then permeate to get fluids through, ours is very much still looking at the monobore system or the ground source heat pump solution, but looking at deep depths. And we've done a lot of technology sort of innovation around this, looking at existing oil and gas technology. How can we take that from the shelf proven technology and put it in a different aspect? So we all know that the biggest chunk of our decarbonisation, as Neil's mentioned, it's a big challenge. We've got this 2050 legal obligation to get there, and most people don't realise that actually heat is the biggest source of our energy drive, which was related to heating and cooling. Is the biggest part of one of our energy drives that we have to do. And that really, that's a sort of pretty staggering number when you look at that globally. So our monobore system is very much focused on doing this in a way which is sustainable, without environmental damage. So we're really looking at how can we do this without getting into the reservoir in the ground. How do we do this in a closed system which has no environmental impact, no induced seismicity and things like this, which geothermal and other things like that do create. So again, our solution is looking at this closed system, fully cased system, but oil and gas magnitude type wells. We're on a stand over there. Some of the wells we're looking at drilling maybe 5, 6, 7 kilometers deep, but we are looking at power generation from these wells as well as just the heat and cooling aspect of them. So a lot of people don't realise, the general common fault with perception of geothermal in general is people just think that Iceland and California and places like that is suitable for geothermal, and that's absolutely not the case. Everywhere around the world has access to heat. The deeper you drill, the hotter it gets. Some cases have it shallower, some cases have it deeper, but in general, you can make an economic model for geothermal anywhere with the right setup. And it's not always about just plugging in the certain aspects of it. You have to make the setup work. So that's the sort of fundamentals about this. And what makes geothermal, or what makes this aspect work better than others, is when you start looking at mezzanine effects of energy. So if you start with high temperature, with power, yes, you have to drill deeper, yes, it's more expensive, but you have a high temperature, a high value resource, which is power generation, which base load is worth a lot more. The return heat from that, you get a higher temperature, which can then be used for secondary heating or the higher level heating aspects, maybe 70 to 90 degrees. That's industrial process type level heating or large scale district heat networks. Then you have a sort of lower temperature grade that can also be commercialized, which can then be used for things like agriculture and these sorts of things. So if you mezzanine the process, you actually get a multiplier on the return on investment for these types of things. So it's about being innovative and creative with the energy. As Neil mentioned, we've got to get these different things out there, and it's about how we adapt, how we use it, plug and play solutions that we can actually put together and make economical in the process. And that's really been our approach. Coming from oil and gas, we've got 20 million oil and gas wells around the world, and we've got over 2,400 in the UK, of which about 680 are still producing. And one of our big approaches is really looking at repurposing these existing oil and gas wells. So we currently have a number of sites over the UK which we've taken on board through collaboration with operators. And these sites will then prove up the concept and the process moving forward of how to develop these existing wells, and proving up the concept to then develop further wells around them to actually scale up and scale this solution. So this is a typical site which we have here. You can see there it's fairly remote, but it's also right on the edge of a major city. And what we can have here is, you can see the sort of size of this site. So it's fairly large site. You know, these are sort of 100 metres square normally in general, and a fairly suitable site for development. And on this particular site, with existing 3 wells, we're currently looking at around about a megawatt or half a megawatt to a megawatt per well of energy heat, which is currently in place from the actual wells itself. So that energy's all there, and when you look at 3 wells which are already there, 3 megawatts of thermal energy, it doesn't sound a lot, but it's a good starting point for a project to actually sort of kick off and get on board. We've also spent a lot of time in modelling, so we've got a modelling software which enables us to thermally model heat flow laterally, horizontally under the ground, and that enables us to, we've taken this from oil and gas information which is all around the world, so we've started to build up a database which is enabling us to really look at the future of what we can do with energy from the subsurface and how it's modelled. And there's quite a lot of difference between the previous map that you saw, which was from the British Geological Society, which is what is estimated thermal gradients based on boreholes that may be 100 metres deep, 200 metres deep, to the reality of when you start getting down to several kilometres, how that changes. It's not always rule of thumb 30 degrees a kilometre. It changes significantly in some cases. A couple of 100 metres down to 500 metres down can be very different, and we have to learn from that and make that information a lot more available and better for the industry. So this is a typical sort of scenario that we're looking at now. So new housing developments that are being out there, where we can build what we call a innovative energy centre, which could be a hybrid approach, looking at subsurface geothermal for maybe 30 to 40% of the baseload power, including all the heating and cooling coming from that, and then integrated with rooftop solar on properties, with battery storage, and then also thermal storage with tanks, etc., and looking at water treatment on the same site. This takes the ability to put these new developments literally off-grid to a point where you can actually be in a location and create an off-grid solution for energy. And again, this is sort of just a general idea, and obviously this can be scaled multiple ways. So you can have single wells. We would normally put sort of at least 2 wells into this type of operation. Some of the projects we're looking at maybe up to 16, 20 wells, maybe from a minimum of 1.5 to 2 kilometres deep for heating, or up to 5 or 6 for including power generation as well. But the idea is really, it's about how we use the energy. As again Neil mentioned earlier on, it's the use of energy is really important. You know, we don't want to waste energy. We want to make sure, from an oil and gas background that I come from, when you're on an oil and gas platform in the middle of the North Sea or anywhere in the world, you have to reuse everything. You can't emit emissions, so everything has to be captured and reused in that process. All your sewage waste has to be treated, has to be recycled, reused. All your incinerator waste has to be recycled, be reused. So we're used to coming up with these challenges in the innovation in the oil and gas industry of how we live remotely and how we need to live in a combined sort of community where everything has to be recycled and reused. And then again, sort of looking at the energy we have, you know, we have a huge amount of potential renewable energy available to us, but we don't have a lot of baseload renewable energy. And I'm not going to slate nuclear, because I think nuclear is everything plays in the mix, and oil and gas will still play in the mix for many, many decades to come. But it's still not really a clean solution. So really, the only way to really look at the future of clean energy has to be looking at the subsurface for baseload energy, because wind and solar won't give us that process for continual baseload energy. And things like battery storage over time, these are going to become a lot more expensive, a lot more hard to get because of rare earth metals and all this sort of stuff. So we have to be looking at really where a baseload energy can play a bigger play in this moving forward. And like everything else, the more we do of it, the cheaper it'll get. in the process. And our business is really trying to provide energy to a point, which then enables lots of these suppliers and contractors here to actually then become part of that integrated process. So we're an energy business. We've set ourselves up to be a developer of energy and incorporate a lot of the services and infrastructure and the technologies and the supply chain which are at these type of events in this process. So we encourage like a lot of these companies here to come and speak to us, because we are looking for partners and collaborators in this process. And again, I think, from my bias point of view, I think I like that picture there a lot better than the other two, basically on how we're going to be seeing our future with renewables if we're moving forward. I think we have to be very conscious of the space we have, the land we have, and the use of that land. And the subsurface enables us to take energy and also keep very much that energy under the ground and still keep a very small footprint of an energy centre on the surface. That's all from me.